Good afternoon, everyone. Again, today we will have some more concepts on engineering mechanics. So, already we have discussed the various concepts regarding engineering mechanics. We have seen the various branches in engineering mechanics. We have seen the various definitions related with the engineering mechanics. We have seen the various laws, that is, the Newton's first law, second law, and third law, with some examples we have discussed in previous lectures. Also, we have discussed the resolution of forces in the previous lectures. Principle of transmissibility and principle of parallelogram theorem also, law also we have discussed. We have discussed about the triangle law also. So in last lectures we have covered various concepts regarding engineering mechanics. Again, today we will have some more concepts regarding related with the engineering mechanics. The most important is nothing but a moment. Okay, so there is an example here. When a force it has been applied in order to have in order to remove this, when a force it has been applied, it is making an angle of 90 degrees. Okay, so what is a moment? Moment is nothing but a, it is known as a turning effect of a force. It is also known as a turning effect of a force when we are applying a force with which is applied at some distance. Okay, when a force it has been applied at some distance, it is nothing but it results in a moment. Okay, it results in the formation of a moment. The moment of a force about any point is defined as force into perpendicular distance from the turning point. This it is very important that it should be the force it has been applied, and it is the distance it should be perpendicular to the force. Okay, the force into perpendicular distance from the turning point to the line of action of the force, it is nothing but a moment. So movement is nothing but equal to force into distance. So what is the unit of the force? We have already discussed. We have discussed that there in previous lecture that 1 kgf is equals to 10 newtons. We have seen the differentiation of weight and mass also. And again, what is the unit of force? Moment. Unit of moment is nothing but force. It has been measured in newtons, whereas distance it has been measured in meters. So therefore, the unit it comes to be Newton meters. Again, movement it can be applied in clockwise as well as anti-clockwise directions. So again, it may be clockwise directions, it may be in anti-clockwise directions. Clockwise direction it has been considered as positive, anti-clockwise it has been considered as negative. Again, there is a simple example in this. In order to have a simple concept of movement, here a force 25 newton it has been applied here, which is horizontal force it has been applied. And according to the definition of movement, the perpendicular distance here, there is the hinge provided in the door, and here the force it has been applied of 25 newtons force it has been applied, and the distance is nothing but perpendicular distance is nothing but the 1.2 meters. Whereas again, there is inclined force of 40 newton it has been applied, whereas it is having again a perpendicular distance of 0.7 meters. Okay, the 0.7 is nothing but the perpendicular distance of this 40 newtons. This 40 newton it has been applied inclined, whereas 25 newtons it has been applied at horizontal. So what is moment? Again, same, force into distance. The first we will calculate for this 25 newtons. So for the 25 newton force, moment is equals to 25 newton into distance is nothing but 1.2. So in simple multiplications, 25 into 1.2, it comes to be 30 newton meters. That is clockwise, because it is moving clockwise. Therefore, we are considering this as clockwise. Whereas this moment force into perpendicular distance again, but here it has been anti-clockwise. Okay, so here 40 newton force it has been applied. Again, it is having a perpendicular distance, because this 40 newton it is inclined, and it is having a distance perpendicular to this. 0.7 is the perpendicular distance. So 40 into 0.7 it comes to be 28 newton meters. But it is about this hinge. If we are rotating this about a hinge, then it comes to be anti-clockwise. Again, this 25 about this hinge it comes to be clockwise, whereas this 40 newton about this hinge it comes to be anti-clockwise. Okay, so in this way we have calculated, we have discussed the concept of movement, and we have calculated the different quantities. That is, we have calculated the movement as 20 newton clockwise and 28 newtons again anti-clockwise. Again, we are having a concept of this couple and torque. Again, the simple concept it has been discussed related with the couples and torque. What is a couple? Couple is nothing but when two equal unlike parallel forces separated by a definite distance form a couple when there is when two parallel forces are acting. But this parallel forces, one thing it is to be kept in the mind, it should be unlike parallel forces. Okay, unlike in the sense, it is having one force, it is applied in upward directions, another force it has been applied in the downward directions, and it has been separated by distance d. So it will results in a formation of a couple. So this two force will form a couple, because it has been separated by distance d. When it has been rotated in anti-clockwise directions, it is rotating in anti-clockwise directions. So again, what is the unit of this couple, or force into distance is nothing but same, moment and couple is one and the same. But here couple, in couple, two parallel forces it has been applied. Here we are having two parallel forces. Here two parallel forces it has been considered here. So, and it has been separated by distance d. Okay, so couple is equals to force into distance, one of the force into the distance between the forces. Okay, torque is another name of the total moment of a couple. Again there is an example for this. Again there is 30 newtons force it has been applied in clockwise directions, here in rightward directions, and 30 newtons it has been applied in left side directions, and it has been separated by a distance of 0.4. Okay, there is a simple example for this couple, and again it has been moving clockwise. Therefore the quantity, how to find out the couple, the 30 into 0.4 is nothing but the clockwise movement. Again this distance, it is a 40 newton force it has been applied, and it has been separated by distance of 0.3 meters. So these are the examples for the couple and torque. Again in this, it has been in clockwise directions, it has been measured in clockwise directions. This is also it is in clockwise directions, whereas this part it is also in clockwise directions. Just we are having a multiplication of this. 40 into 0.3 is nothing but the quantity of a couple. Again this 30 into 0.4 is nothing but the same. Okay, so this is nothing but an example for the couple. The couple unit already, it is the same as the moment. It has been newton meters. Again, what are the different characteristics of a couple? The algebraic sum of magnitude of the member forces forming a couple is always zero. The algebraic sum of the magnitude of the member forces forming a couple is always zero. Again, second point related with this is nothing but the couple can be balanced by a couple only when which has same moment and opposite sense, because when two different forces with opposite sense, unlike parallel forces, it has been applied with same, if it is having 20 or 10 newtons, so the quantity is same, 10 or 20, but it has been separated by distance d. Okay, what is the third point? Moment of a couple is fixed, and it does not depend on the moment centers. Okay, so these are the characteristics of a couple. Again, comparison of torque and moments. Here we are having the comparison between torque and moment. Torque is a moment of force, whereas a moment is a static force. Whereas second point related with this is nothing but it is often presented as a Newton meter per revolutions. Again, the second point related with the moment is nothing but the moment is typically presented as Newton meters. Already we have discussed this. The unit of this moment is nothing but Newton meters. It tends, third point is differentiation is nothing but tends to be used when there is an axle or pivot to be turned around, whereas tends to be used in essentially non-rotational situations such as analysis of forces on a beam. Whereas twisting effect, fourth point, twisting effect produced by force, whereas this is nothing but a turning effect. Okay, so here in moment we are having a turning effect, whereas in torque we are having a twisting effect. Here is an example for this. Here the two forces it has been separated by distance d, whereas in movement it in case of movement there is a perpendicular distance d is applied. Here force we are applying with the of this hand, we are applying a force, and it is making an angle of 90 degrees. Okay? Perpendicular distance. Again we will solve some more problems related with this concept. Again we will have some more problems related with this. So these are the problems related with, we will solve the problems related with resolution of forces. Yes. Already we have discussed this principle of transmissibility. So in short, we will have a short review of this principle of transmissibility. Again, a force, it has been applied at point A. Along the same line of actions, it has been transferred here because from A point where it has been transferred at B point, the same sense of force it has been transferred along the same line of actions. So it is nothing but the already we have discussed, that is nothing but principle of transmissibilities. Okay. Okay, next is nothing but resolution of forces. Breaking of force into two components, already we have discussed this breaking of forces in two components, that is basically horizontal and vertical force. We are considering this horizontal and vertical force. So conversion into two is nothing but resolution of forces. Okay. So again, if it is making an angle of theta with horizontal, if we, force it has been applied or it is making an angle of theta, then we can resolve it along x and y directions. So we are considering this as fx as horizontal directions, whereas fy as a vertical directions. Again, it is making an angle of theta with horizontal, so fx is nothing but the f cos theta, whereas vertical force fy is nothing but the f sin theta. Again, if it is making an angle of theta with the vertical axis, with the vertical y-axis, then this vertical component fy component will be cos theta, because it is making an angle of theta with the vertical axis. Therefore, this will be the cos theta, whereas fx other angle will be the sin theta. The fx is nothing but equal to f sin theta. Again, this concept is also important related with this. If it is making an angle, or if it is having x and y axis, but it is making an angle in this slope side, it is having a sloping of x and y directions. So how to find out the angle made? Because in this case it is making an angle here, so therefore we can use this. Here it is making an angle of this part. Yes. So it is making an angle of here, it is making an angle of theta here. So we have to how to find out this angle theta. So by the concept of this fx upon, if we are considering this as fx, if we are considering this as fx, whereas if we are considering this as fy, so fx upon x, there is a parallel law of triangles. By law of triangles, this is horizontal side is there, fx is horizontal, whereas x is also, the fx upon x is equals to fy upon y, that is equals to f upon d. So f is nothing but the force and its distance we are finding, so f upon d. So in this way we can calculate the thing. When two points to remember while resolving forces, we have to find out its directions is very important, whether it is moving towards right or towards left. These points are very important when we are calculating the when we are resolving, or when we are calculating the resultant of a force. So therefore directions plays an important role, and where it has been applied. Okay? A point position of an angle, it has been very important. So directions as well as position of angle, it is very important, because if it is making an angle with x-axis, that means cos theta will be x coordinate will be fx will be cos theta, and fy will be sin theta. Again, these are the simple sign conventions. Rightwards it has been measured, it has been taken as positive, whereas left side it has been from right to left. When a force it is moving from right to left, it has been taken as negative. When it has been moving upwards, it has been taken as positive, whereas if it is moving downwards, it has been taken as negative. Again, position of angle. No. How to find out the different positions of angle? That is, component adjacent to angle is taken as cos theta, while other component is taken as sin theta. Okay. So already this angle, it has been making this inclined force, or this force which is making an angle of theta with the verticals. That means fy will be cos theta. So here we are taking fy as the cos theta, and whereas fx is sin theta. But this according to the sign conventions, according to the sign conventions, if it is cos theta, then it is moving towards downward directions. So downward directions, it has been taken as negative, whereas fx, it has been measured as minus sin f sin theta. Okay. Again, important points related with the resultant force. Here resultant force, single force which produce the same effect on the body as the number of forces are producing on it while acting simultaneously. Okay. There is a single, we are converting, when number of forces are acting on a body, then we are converting that different forces into a single force. That single force we are representing as the resultant. Okay. So we have to find out in this case fx, that is all summation of all forces along x directions. Then we have to find out the summation of all forces along y directions. And what this resultant r says, so r is nothing but equal to square root of summation of all horizontal forces and summation of all vertical forces. Again, theta is nothing but tan inverse of y by x, that is theta is nothing but slope, that angle made by the resultant. Now how to find out the position of this resultant where it has been applied? So we can find out this, the position of the resultant by tan theta is equals to tan inverse of summation of fy by fx. Okay. Again, if resultant is horizontal, then we can have resultant is horizontal, that means y component is 0, therefore summation of fy is 0. And if resultant is horizontal, what it means, r is equals to summation of fx. Okay. So resultant is when the resultant is horizontal. If resultant is vertical, that means fx component is 0. This is an example for this. If the resultant is vertical, that means horizontal component is summation of all horizontal forces is 0, whereas vertical force resultant is vertical, therefore r is equals to summation of fy. Also, resultant acting at negative x-axis, that means if it resultant acting at negative x-axis, that means left side direction is there, therefore it is negative. Whereas resultant acting at negative y-axis, that means downward directions is there. These are the important terms related with the which has been used in the questions. So therefore this will be this we have cleared. If it has been asked that resultant is horizontal, what it means? So it is having a double meaning in which fx is 0, fy is 0, whereas resultant is fx. In same way, if the resultant is vertical, what it means? So we have discussed, if the resultant is acting at a negative x-axis, what it says, it is moving towards left, where a negative y-axis, that means it is moving towards downwards. Okay. Again, moment, we have already discussed this moment, its unit we have already discussed this. Okay. If it is having, if we are having, it is a simple example for this sign conventions. If the number of forces are acting, if these are the, there is a beam or there is a member, a horizontal member in which these are the forces. Okay, a vertical force, it has been applied, P vertical force is applied, whereas this Q is also applied, whereas R is downward force applied, and it is having some distances. X in centimeters, it is having some distances, whereas Q to O, it is having a Y distance in centimeters, whereas Z distance in centimeters and W distance in centimeters. Whereas this horizontal for vertical force, it has been applied downwards in downward directions. So then we are finding out the movement of all forces of movement at a point O. Okay, movement of force P at a point O. Okay, so we are finding out the movement of point P at moment of force P at a point O. Okay, moment of force P at a point O. So this force P, it has to be taken care in the we have to take moment at this point O. So we will rotate this in clockwise directions, because we will see, we have to see rotate this in the clockwise directions. So this, it is separated by distance x plus y, therefore P into x plus y, it has been measured in centimeters, the Newton centimeters. Again, this Q force about U, O is nothing but again clockwise, but it is separated by distance y centimeters. So here we have taken as Q into y. Whereas R about this, it is again, it is having a clockwise movement, whereas it has been separated by distance z centimeters. So R is the force, R into z is nothing but the and its unit is Newton centimeters. Whereas S, it is moving towards, to take this force S over the point O. Again, it is having a clockwise movement, so therefore it has been separated by distance of z plus w. So here we have taken as w plus z, or z plus w into the force. Force is nothing but S, Newton centimeters. So in this way, here we have taken the moments. Again, this concept for anti-clockwise directions. Now, again, the moment in anti-clockwise directions, we have taken this. Now, again, we have to take this force P about O. Again, it is in anti-clockwise directions. We have seen this problem in clockwise directions. Same, it has we have to take the moment in anti-clockwise directions. Again, x plus y. Again, this force, it has been it is we are rotating this force about O, therefore it is in anti-clockwise direction. It has been separated by distance x plus y, therefore it is in anti-clockwise directions. Again, Q force, we are taking movement about point O. again q about this point o is nothing but and in anti-clockwise directions. So moment of q about this point o is nothing but q is the force. Again it has been separated by distance y, therefore minus q into y is nothing but the its value. These are the just the simple concepts related with the moment, depending upon the distances, depending upon the whether it has been applied downwards or upwards. So when different forces are acting on a beam, so we have to find out the moments at different points. So here we are calculating the moment at the point o. Again this moment of the force r about point o, so again it is having in anti-clockwise direction, but it has been separated by distance as z. Okay, so minus r into z. Whereas s also we can have the moment of this s about this, again it is having anti-clockwise direction. What are the distance for the s force? It has been separated by distance as z plus w. So z plus w is nothing but the distance for s. Again we can rotate this about o as anti-clockwise. Again important concept related with the mechanics is nothing but the variance theorems. Okay, the variance theorems is also very important related with variance theorems. So important points related with the variance theorem is nothing but a moment of all forces about any point. Moment of all forces Moment of all forces about any point is equals to moment of resultant about the same point. So here we have moment of all forces about any point. So here moment of all forces about point, summation of moment of all forces about any point is equals to moment of resultant at the same point. Okay. So here we have taken the example of O, that is the point O. The moment of summation of moment of all forces about the point O, that is equals to moment of resultant about point O. Again, variance theorem is used to locate the position of resultant. If x is the position where resultant cuts x-axis, or y is the position where the resultant cuts y-axis. Okay. Again, summation of fx and summation of fy. Here we are finding out. We are taking the moment of all forces about point A. How to find out? So here we are all forces about point O is nothing but summation of fx into, if the force is vertical, that means distance is horizontal. If the force is horizontal, that means distance is nothing but the vertical. Okay. So force into perpendicular distance. If the force is vertical, then we are taking the distance as horizontal, the distance as x bar as the horizontal distance. Whereas if the force is horizontal, then we are considering the distance as vertical, y distance. Again we have already discussed the concept of couple also, when it has been separated by distance d, when two unlike parallel forces, it has been separated by distance d. So how to find out the here these two forces, it is producing a clockwise effect, f into d, but it is having a clockwise effect, therefore plus f into d, plus f into d we are considering for this. The f into d is nothing but the it is the nothing but the quantity of couple. Okay. Again again here are here we have discussed this. We will solve some more problems related with this. Resolve forces p, q, r, s and t in figure into components along x and y directions. So we are resolving the forces along x and y directions. Here different forces are acting. Here p force, it has been making an angle of 30 degrees with horizontal. Here it is making an angle of 30 degrees with horizontal, whereas it's 200 newton is its capacity. P is net, it is having of 200 newtons, whereas T, it is making an, it is having us in the form of slope. It is having a horizontal as 1, whereas vertical distance it has been taken as 2. What about the quantity? T is having an intensity of 53 newtons, whereas Q is vertically upwards, which has been applied vertically upwards. It is with a quantity of 100 newtons, whereas r 40 newtons, it is making an angle of 30 degrees with verticals. And again s, it has been there is a force s which is having 80 newtons force, it has been applied. Again it is having 3 by 4 the 3 distance, and 4 is the vertical distance. Here these are the number of different forces which are acting on this. So one by one we will solve, and we will find out the resultant for this, and we will also find out the its directions. Okay, x and y directions. So here first force is nothing but P, that is 200 newtons. So it is making an angle of 30 degrees. Again Px is horizontal distance. Px is horizontal distance, whereas horizontal we are resolving this P horizontally. Therefore we are taking this horizontal as Px, whereas Py we are taking as vertical. It is making an angle of 30 degrees. So it is as it is making an angle of 30 degrees with horizontal, therefore p, that is nothing but equal, px is nothing but equal to p cos 30. So here 200 into cos 30, so here it is making an angle of 30 degrees, therefore cos 30 is horizontal, therefore p cos 30, 200 into cos 30, it comes to be px as 172.2, 173.2 newtons. Again this py, opposite, because we are taking this as cos 30, next is nothing but the sin 30. Okay, so sin 30 is again 200 sin 30, so 200 sin 30, it comes to be py as 100 newtons. Again the same way, we have to take this second force, we are calculating the second force as q. Again q is applied at vertically upwards, that which is having a quantity of 100 newtons. So and again this with help of this 100 newton, that means qx is nothing but 0, whereas directly qi is nothing but 100 newtons, because it has been applied on vertical y-axis, it has been applied on vertical y-axis. Therefore this directly we have taken as qi as 100 newtons. Again same way, in the next quadrant, in where here force r, it has been applied at this, it is making an angle of 30 degrees. Again as it is making an angle of with vertical, that means vertical component we will take as cos theta and horizontal we will take as sin theta. Again ry we are taking as vertical component, whereas rx we are taking as horizontal components, but ry we are taking as it is making an angle of 30 degrees with vertical, therefore this part will be cos theta. So rx is equals to, this will be sin theta, as it is left side directions is there, therefore we are taking this as negative sign. So minus r sin theta, minus 14 to sine of 30 degrees, it comes to be rx as minus 20 newtons, whereas ry we are taking as ry cos theta, and it is moving upwards, it is moving upwards, therefore we are having the quantity as r cos theta, that is 40 cos of 30, therefore ry value is having a 34.64 newtons, therefore this value comes to be 34.64 newtons. Same way second force, it has been applied as s force, we are applying the force, next force as s. In this figure again there is a force s, it has been applied here. Here there is a third force s, it has been applied, but it is having some distances in horizontal as well as vertical distance, that is 3 is the horizontal distance, it is in the form of slope, and vertical it has been given as 4. Okay, so here we are taking this 3 as a horizontal, it has been already been given, and 4 as a vertical. So how to find out the distance? Again by Pythagoras theorems, if it is making an angle of opposite upon opposites, by how to find out the distance by Pythagoras theorems, that is the opposite upon adjacent, opposite plus opposite square plus adjacent square. Okay, so square root of 3 square plus 4 square, it comes to be 5. That means the distance for this is nothing but 5 meters. Okay, again we have to find out the values for this s upon d, that is equals to sx. This sx is parallel to this distance 3 meters, so we are taking this as x. Already in previous videos we have seen that how to find out the distance. So we can find out the distance by this concept, by similarity of triangles also. So we are using the similarity of triangles in order to find out the distances, because here the distance is here the theta is not directly given, we are finding out indirectly finding out the theta. Therefore, s upon d is the nothing but equal to sx upon x, that is equals to sy. That is again this y. Sy is the vertical force. While resolving this s, we have taken this as phi. Again, this that is equals to, by similarity of triangles, we are taking this as y. Okay. Again this sx upon x, that is equals to, as it is moving downwards direction, therefore it has been taken as minus s upon d, because it is moving downward in downward directions. If it is moving in upward directions, then we can take as positive, but here it is 80 newtons, it has been moving downward in downward directions, therefore minus s upon d. So minus 80 upon what is the distance d? By this hypotenuse rule we have calculated this as 5. So s upon d is nothing but 5. So here Sx in by simple cross multiplications, what is the force Sx? Sx is again taken as by simple calculations, it has been negative. Therefore, this directions is also left side. That means itself indicates its direction as negative. Okay, so Sx is equals to minus 48 newtons. Same way by similarity of triangles, we have taken these two terms. First, we have taken these two terms. Next we will take this first term and last term, that is sy by y is equals to minus s upon d. Again why we have taken this minus sign, the because it has been this s force, it has been taken in downward directions, it has been applied in downward directions, so minus s upon D. So Sy upon what is y? Y is nothing but here it has been taken given in this case is 4. Okay. Here we have taken as 4, that is equals to minus s, that is nothing but this 80 newtons divided by again the distance d we have to calculated already calculated the distance as 5. Okay. In this way Sy by this calculations we have calculated Sy as minus 64 newtons. So in this way we have calculated or we have resolved this s when directly theta is not given in some problems when theta is not directly given. So then we can, in this case we can find out the, by similarity of triangles we can find out the sx and sy. We can resolve this and we can find out the by resolving this we can find out the in horizontal directions as well as in vertical direction by this similarity of triangles. So this concept of similarity of triangles is very important in order to find out the horizontal as well as vertical components. Here a horizontal component is also left side, that is in negative directions, whereas this sy is downward directions, therefore it has again taken as negative directions. In this case is very important. Directions are very important in order to find out this. So here a small figure we are representing this. Here we are having a theta here. We have to find out theta also. So how to find out the theta? Again, here this theta it has been transferred here. Here we are transferring this theta. So this theta we are calculating as tan theta. Tan theta is nothing but opposite upon adjacent. So here opposite is 4, adjacent is 3. So theta is equals to tan inverse of 4 by 3. It comes to be 53.13. Same way, if it is sx, if we are finding out sx, then this resolution of by resolution forces s cos theta we will take. So s cos theta, sx is equals to cos theta with minus sign. Why minus sign? Because it is acting left side, because it is moving left side. So minus s cos theta. So minus 80 already, this 80 it has been given. Cos theta we have taken as 53.13. Theta we have already calculated by this triangle slope. So minus 48, whereas sy is it comes to be minus 64. In this way, this 53.13 we have calculated the angles, that is theta is equals to 53.13. Again there is force T which has been applied. Again this T it has been applied and it is having again this horizontal distance as 1, whereas vertical as 2. Again this horizontal, by similarity of triangles, first we will find out this distance D by this hypotenuse rule, that is D is equals to square root of 1 square plus 2 square. That is the opposite. Here suppose we are considering this along this vertical, this angle it has been making with vertical. So here we are considering theta which is making with verticals. So here we are having theta with vertical. We are taking the theta with verticals. Okay. So here we are taking this as 30 theta. Okay. Again this theta will be transferred here. Here we are transferring this theta here. So d is equals to square root of 1 square plus 2 square, that is equals to square root of 5. Again to t is given as 53. Again it is moving downwards. Okay. So again this t is moving downward in downward directions, but it is depending upon the quadrant we will find out. So tx td upon first we will take this as tx by x. First term is we are taking this dx and its parallel sides by similarity of triangles is x. Okay, that is 1. That is equals to, again t is nothing but 53 newtons is the quantity for this. Intensity for this t is given as 53, whereas d is nothing but square root of 5. Okay, square root of 5. In this cross multiplications we can have, and this dx is moving rightwards, therefore we have taken as positive. Okay, it is moving rightwards, that means it is taken as positive. What about ty? Ty is again first and last third term. We are multiplying this. We are equating this capital D upon small d, that is equals to ty by y. Again, why we have taken a negative sign? Because it is moving downwards. Okay, so it is moving downwards. Therefore, we are taking this as negative sign. Again ty by y is nothing but 2. Again that is equals to t intensity for this is nothing but 53 newtons. D we have already calculated here as square root of 5. By simple cross multiplications dy comes to be 47.4. How to find out theta? Again theta, simple calculations. Opposite upon theta is equal to tan inverse of opposite upon adjacent. Here opposite side is 1 and adjacent is 2. It comes to be, theta comes to be 26.56. So in this way we have calculated this theta is 26.56. And tx again, we can find out this tx as sin theta, whereas ty as cos theta. Okay, so t sin theta's intensity for this is 53 into sine of 26. Already we have calculated here 26.56, so it comes to be tx as 23.70 newtons. Again, in same way, ty is nothing but this component, so it is nothing but equals to minus t cos theta. Why cos theta? Because it is making an angle of theta with vertical axis. It is making an angle of theta with vertical axis. So ty is equals to minus 47.4 newtons. So in this way, tx and ty we have calculated here. In x directions it is positive. Why? Because it is moving rightwards, whereas in y direction it is negative, because it is moving in downward directions. Okay, so minus 47.4 newtons. So in this way we have calculated the various components, and depending upon this we can find out the resultant also. But in this problem we have resolved this forces, and we have while resolving the inclined forces we have calculated its x and y components. Same way, there is an example for this. Here also we will find out. Here in this case we will find out the resultant. In previous problem we have calculated the x and y components, but here in this case we will find out the resultant of forces. Okay, here we will find out the resultant of forces. So here P force is nothing but 200 newtons, which is acting of which is making an angle of 30 degrees with horizontal, whereas this Q is nothing but 100 newtons. Again, it is directly upwards, which is along the y-axis, whereas this R force, it is having an intensity of 40 newtons, which is making an angle of again 30 degrees with verticals, whereas this 80 newtons S force is there, which is having an intensity of 80 newtons, but it is making it is having a slope of 3 by 4, which is having a slope of horizontal as 3 and vertical as 4. Again, this 53 newtons, it is having a slope of 1 by 2. Okay. Again, same way we will directly resolve this along the same graph. Okay, along this same we will resolve this. So here P 200 newtons we have resolved here as we have transferred this 30 as in this way. So 200 cos 30 we will take this as 200 cos 30, whereas in opposite in next along y direction we will take as sin theta, so 200 sin 30s, whereas this Q 100 newtons, it is directly upwards. Second force was directly upwards, whereas this R force, it is making an angle of 30 with vertical. That means vertical will be cos theta. So here 40 cos theta we have taken as vertical, so same angle it has been transferred here, and we have taken as 40, that is cos 30 in vertical directions, whereas sin 30 in horizontal direction, that is 40 sin 30. Same way, if we are transferring this, so if this triangle is slided here, so that means this it is making an angle of theta with here. So here we will take this as angle as theta, this we will take this as theta, and this same will be transferred here as theta. Okay, so that means this theta will be there. Theta is nothing but opposite upon adjacent. Theta is equal to tan inverse of opposite upon adjacent. So in this way we can first find out the values. Okay, so here we have calculated theta 1, we will find out theta 1, and same way we will have this as same triangle. By transferring this we will have this opposite upon adjacent, theta is equal to tan inverse of opposite upon adjacent. By the concept of this opposite upon adjacent also we can find out this. So again, theta 2 opposite upon adjacent, we will find out this. Again, its intensity is 53. For this case it is making theta, for theta 1 it has been making with horizontal, therefore this horizontal will be cos theta and vertical will be sin theta. So again, this it has been making with vertical, that means vertical will be cos theta and horizontal will be sin theta. The theta 1, how to find out? Theta 1, that is opposite upon adjacent. The opposite here in this case is nothing but, for this case is nothing but opposite. If we are having this angle theta here, opposite is 4 and adjacent is 3. So here we have taken as opposite as 4 and adjacent as 3 for theta 1 case, and same way opposite upon adjacent for theta 2 case, that is tan inverse of 1 by 2. That comes to be 26.56. Next we are finding out the resultant. Okay, after the calculations or after resolving this in x and y directions, we will find out the resultant force. Okay, first we will find out summation of all horizontal components, then we will find out the summation of all vertical components and its resultant. The resultant, that is equals to square root of summation of fx square plus summation of fy square. and we will find out the directions in this case, whether it is lies in first, second, third, fourth quadrant. Depending upon fx and fy values, we will find out the theta is equals to tan inverse of fx upon fy. So first we will club the all horizontal components. So all horizontal components we will take this case. So here in this figure, horizontal component is nothing but this 200 cos 30, which is moving right side. So it is plus 200 cos 30 will be the first force. What about this second? Second is again 53 sine of theta 2. Theta 2 we have already calculated. Again it is right side directions. So these two are in right side. Therefore this will be positive. But this 40 sine 30 it is in negative directions. So therefore minus 40 sine 30, and this will also be minus 80 cos theta 1. Minus 80 cos theta 1. So here we have taken this as minus 80 cos theta 1. Okay. Here we have taken this minus 80 cos theta 1 and minus 40 sine theta 2, that is 30 degrees. So after simple calculations, it comes to be summation of all fx components, it comes to be 128. So 128.90, it comes to be 128.90. Same way fy components, same way all vertical components we will calculate the same way. 200 sine 30 is all vertical components for this figure. So here vertical components are this 200 sine 30 is in upward direction, therefore it has been taken as positive. Whereas 53 cos theta 2 it is in downward directions, minus sign. This is also minus 80 in minus 80 sine theta 1 in downward directions, whereas this 40 cos 30 it will be in upward directions. That means 1 2 2, these two forces are in positive directions, 40 and 200, whereas this 80 and this 53 it is in downward direction, therefore minus sign. Okay, so in this way we have calculated fy as 123.23 newtons. Okay. Again, how to find out the resultant? The same formula, simple formula to find out the resultant is nothing but square root of summation of fx square plus summation of fy square. Therefore, resultant that is equals to square root of 128.90 square plus 123.23 square. It comes to be 178.32 newtons. So in this way, we have calculated resultant, and depending upon its directions. So fx and fy they both are in positive. Therefore, this lies in first quadrant because fx it is also in positive and fy it is also positive. That means theta and this resultant will lie in first quadrant. This resultant which is having an intensity of 178.32 newtons, it will lie in first quadrant. Okay, it will lie in first quadrant. So theta is equal to tan inverse of summation of fy upon fx. Already we have calculated fy and fx. The theta comes to be 43.71. So in this way, this small figure representing the resultant, which is having an intensity of 178 after calculations, we have calculated resultant as 178.32. It is making an angle of theta, that is 43.71. Whereas after resolving this 178.32, this additions it comes to be 178.32. Okay. So these are the two values fx and fy, that is 128.23. First value was 128.23 and 123 point this. So in this way, last is nothing but resultant of forces. Force system is 178.32 newtons, and it is making an theta, that is 43.71 along with the horizontal axis. So these there simple problems may be there, simple by depending upon the directions. They are depending upon the various directions and along first, second, or third or fourth quadrants, along the different quadrants. We have to find out, or we have to resolve the forces, and we have to find out the resultant and its directions. In this case, we have calculated the resultant, and we have find out its directions. Okay, these are the simple points it is to be taken into care. If the resultant, already we have discussed this, if the resultant is making an angle of theta with vertical, that means ry is nothing but cos theta with positive sign. Here it is minus r sin theta, simple way. Again rx is nothing but r cos theta with positive sign, and this is also with positive sign. Okay. Again, if sub force F is acting, the force system shown in figure produces a resultant of 600 newtons. In this 600 newtons resultant it has been produced. The force system shown in figure produces a resultant of 600 newtons, which is acting up to the right. That means the resultant is along the y-axis. Summation of Fy is equals to resultant, that is having a 600 newtons, whereas Fx will be 0, because in this statement itself it is having to things, that means resultant is along y direction, that means x direction is 0. Okay? The force system shown in the figure produces a resultant of 600 newtons acting up to the right at an angle of 60 degrees with x-axis. Find the values of f and theta to produce the resultant. Okay, to produce the resultant. So here figure it has been given where f, it is the force, it has been acting and it is making an angle of theta with horizontal, whereas 240 newtons force, it is making an angle of 30 degrees again with the horizontal, and there is a 500 newtons which is acting left side in left directions. Okay, it is acting left side, whereas resultant acting up to the right at an angle of 60 degrees. So it is making an angle of 60 degrees with x-axis, and it is having an intensity of 600 newtons. That means resultant, it is making an angle of 60 degrees. That means resultant will have x component as well as y components. That means fx value will be 600 cos of 60, whereas fy value will be 600 sin of 60. So here we are resolving this resultant along x and y directions. So here we have taken as 600, that is cos of 60 degrees, that is fx we have taken as 600 cos 60, whereas fy we are taking as 600 sin 60. The value comes to be 600 cos 60 as fx value. We are resolving this along x directions and we are resolving this along y directions. Okay. Again, depending upon these figures, we are resolving this force F, which is making an angle of theta. That means this horizontal component is cos theta, whereas vertical component is sin theta. Again, this 240 newtons force, it is making an angle of 30 degrees with horizontal. That means 240 cos 30 and 240 sin 30 in other directions, downward directions. Here it is in rightward directions and here it is downward directions. So while resolving this, one thing it is to be kept in mind, we have to have in x directions, we have to move this force in along x direction. So we are moving this 240 along x direction. That means x is horizontal force and y is nothing but sin theta. Okay, because it is making an angle of horizontal, so horizontal is cos theta, whereas 500 newton is directly it is acting right side. Okay, negative right side. So resolving all fx forces, fx forces, summation of all horizontal forces. So here horizontal force directly is given as minus, therefore minus y, because it is moving left side. So minus 500 plus what about this f cos theta, it is moving right side, so positive, whereas 240 cos 30 again it is positive. What is the value of resultant here? Fx is resultant here we have calculated as 600 and it is positive. So plus 600 cos 60 is there. Resultant is positive because it is lies in first quadrant, therefore positive. So with the help of this value plus 600 cos 60 we have taken, whereas simple multiplications we have, simple additions we have taken this. So f cos theta minus 500, that is plus 240 cos 30. Simple calculations are there. We have taken this f cos theta, or we have taken this 600 cos 60 and minus 500 we have taken left side, and 240 we have taken again this, so minus, so f cos theta it comes to be this whole equations. Now again f cos 30 with simple additions it comes to be 592.15 newtons. So f cos 30 it comes to be 592.15 newtons. Same way fy we are resolving this along y directions. So y directions is upward f sin theta and downwards minus 240 sin 30. What about the third resultant? It has been given as plus. So therefore we will take this as plus 600 sin 60. Here in this case is plus 600 sin 60, whereas this is nothing but f sin theta minus 240 sin of 30. Simple addition subtraction concept. With the help of addition and subtractions, we have taken this minus 240 left side, so it comes to be 600 sin 60 plus 240 sin 30, it comes to be f sin 30 times f sin theta, and the value comes to be 639.61. Same way, we are finding out the theta by simple dividing equation number 2 with equation number 1. So f get cancels, tan theta sin theta upon cos theta is nothing but equal to tan theta. So theta is equals to tan inverse of tan theta. After simple divisions, this 639.61 divided by 592.15, simple divisions, it comes to be 1.08. So theta it comes to be tan inverse of this, it comes to be 47.2. In this way we have calculated theta. Then we have to find out the force. So f cos theta is there, which is having a force value f cos theta as 592.15. So with help of this 592.15 we have to find out the force f, by simple divisions, 592.15 divided by this cos theta, the force comes to be 871.52 newtons. Same way we can correlate, or we can have a check for this F cos theta also. The force F will be same way we can find out with the help of F cos theta, or we can find out with the help of the F sin theta. The force will be same. So force we have calculated, and we have calculated the thetas. Okay? So these two things were very important in this calculations. We have calculated theta also. We have calculated the force in this concept. Okay? Again, problems related with again the quadrants. Again, problems related with the different quadrants. Again, in this problem, there is again a force which has been applied F, but it is making an angle of, it is having 3 by 4, horizontal as 3, vertical as 4, and there is an angle which is making an angle of alpha here, and again there is this x and y directions is along inclined. Okay, so here in normal cases x and y directions they are vertical, but here in this case it has been inclined, because in normal cases we are having x in along x first quadrant. Here we are having x directions, and here we are having y direction. But in this case we are having x and y directions here in perpendicular directions. Okay, here it is taken as x direction here and y direction as this, whereas the force F is it has been applied, which is making an angle of alpha 3 by 4, whereas this x and y directions, this plane again it is making an angle of theta, that is 1 by 1 as vertical and 2 as horizontal. Okay, so again this concept is important related with this. First we will find out the we will transfer this alpha. Okay, so first we will transfer this along the horizontal directions. If we draw a line here, so this alpha will be transferred horizontally, because this alpha it is making with horizontal. So then we can, by opposite angles, we can transfer this alpha directly to this. Okay, so this alpha will be we have transferred here. How to find out this angle? This angle can be found out by tan inverse of opposite upon adjacent. The opposite here we have taken as 4. It has been given as 4, and here we have taken as 3. Adjacent we have taken as 3. So 4 by 3 it comes to be 73.13. That is alternate angle or opposite angles. So here alpha we have transferred here. Here we have transferred this alpha. That means this force F it is making an angle of alpha as 53.13. Again theta, so theta is again this x directions, this x axis it is making an angle of theta. So again we can have this theta as we can find out this theta angles, corresponding angles, that is again opposite upon adjacent. We can, with the help of this we can find out the value as 26.56. This is x axis is there. Okay, so this x axis is again making an angle of theta which is having a value of 26.56. That means we have calculated this small angle as thetas, and this complete angle we have calculated as 53.13. So this complete angle, this force F is making with the horizontal as 53.13, whereas this x axis it is making an angle of 26.56. So in this way we have calculated the angles, that is alpha and theta. Then what is the angle made in between these two? The 53 is the total angle, whereas 26.56 is the smaller angle. So we can subtract this 53.13 with the 26.56. So it comes to be 26.57. It comes to be 26.57. Okay. So here we have calculated this angle as 26.57. So along the x and y direction, why we are calculating all these things? Because this F force it is inclined, it is making an it is applied at inclined x and y axis. Okay, if it is applied on horizontal x and vertical y axis, then the problem is simple. But here this force is making, or it has been applied at some inclined plane. So here inclined plane is x and y, and we have calculated this force, the angle made by this force with the horizontal x-axis. We have calculated this angle made by this force with horizontal axis as 26.57. So here we have calculated as 26.57. Next, again, which things are given? So here fx is given as 893, which has been given the f cos theta. The f cos theta, that is equals to fx, it has been given as 893. So how to find out f? F is nothing but simple divisions is there. 893 divided by, that is cos of 26.57. So here we have calculated F force as 998.44 newtons, whereas Y component is again F is we can also calculate its Y component. So Y component is sine theta. Simple way में Fy is nothing but sine theta. So F sine of 26.57. So in this way, simple calculations, already we have calculated force as 998. We are keeping the values as 998 point this, and its sine of 26.57, it comes to be Fi as 446.59. So in this way, when the force F it has been applied at inclined planes, when it is been applied in inclined planes, then in this case we can find out the value of Fx and Fy. Okay. Again, this is an example which is again it has been important related with the inclined planes. Here the force W, there is a weight W which is been applied. Here there is a block in which this block is resting along the inclined plane, which is making an angle of 30 degrees. This block is resting on an inclined plane which is making an angle of 30 degrees. So here we will read the block shown in the figure is acted upon by a weight of 400 newtons, which is vertically acting downwards in vertically downward directions, whereas a horizontal force F is nothing but 600 newtons. Here force F it has been applied here horizontally, force it has been applied in upward direction in these directions, and force P it has been applied here which exerts and the force P exerted by inclined plane. Here force P which is making an angle of 45 degrees and 75 degrees, because this total it is nothing but we can, if we are drawing this perpendicular, total it has been taken as 180 degrees. So therefore here it has been given as 45 degrees and 75 degrees. The resultant of these forces is parallel to incline. Determine P and resultant force. Okay, so we have to find out the P force and the resultant. So with the help of this figure we will find out the force P and its resultant. Simple here, most important is X. It has been this X and Y, that is the axis along X and Y planes. In this case X we have taken in upward directions, we have considered along this plane we are considering as positive, whereas along these directions we are considering as Y direction. That means this 400 newton it is to be resolved along this X and Y directions. This F 600 newtons it is to be resolved in X and Y directions, and this P force again it has to be resolved along this X and Y directions. Okay, so this X and Y direction it is important because it has been mentioned here. According to this directions we have to resolve the force. Okay. So here for 400, so we will draw a line in this parallel to this X directions. We have drawn a line parallel to this X directions, and Y directions, so we have drawn a line parallel to this Y directions. So again this 60 it is making an angle with X, uh, uh, it is making an angle of with X axis. So therefore 400 cos of 60 and 400 sine of 60. Same way we have to resolve this 600 newtons which is acting directly horizontally in along this inclined X and Y directions. Okay, so here it again it is making an angle of the this force it is parallel to along X directions, and this force 600 sine 30 is parallel to this Y directions. Again it is making an angle of 30 degrees. Therefore we will have cos 30 as this in this direction we will have as cos 30, and in this direction we will have as sine 30s. Again this it is making an angle of 75 degrees. So we have resolved this by opposite angles. We have taken this, or we have resolved this, we have drawn a horizontal, and we have by opposite angles we have transferred this 75 here also. We have transferred this 75 here. So we have transferred 75 here. Okay. Here we have transferred this 75 degrees. So this opposite by opposite this here we have transferred the 75 degrees. That means this horizontal in along horizontal directions it has been considered as X, that is cos theta, and along this we are considering as Y directions. So in this way, first we have resolved this along all the components, all the forces we have resolved in X and Y directions, and depending upon this we will find out the resultant. Okay, so resultant again here one conditions for resultant it has been given. the resultant of all these forces is parallel to the inclined. That means it is parallel, the resultant of these forces is parallel to inclined. So we have to find out first, according to these conditions, the resultant force is parallel to the inclined. Okay. So two conclusions can be made above statement, that is the resultant is as the resultant is parallel to the inclined, that means the resultant is along x-axis parallel to the inclined, that is inclined plane. The inclined plane it is along the x directions, that means resultant is parallel to the x-axis. Okay. That means Fy will be 0 and resultant is nothing but equals to Fx is that is equals to the resultant. In this way we can find out Fy as we are by taking this condition Fy is 0. The first summation of all y components by taking up upward as positive and this inclined plane depending upon this inclined plane because these directions it has been given. Okay. This x and y direction it has been given. Here x was given, here x was given, and this y was given. Okay. So depending upon these directions we have to find out this. So first we have summation of all x components we have taken. So we have resolved this and we have taken summation of all x components. So here minus 400 sin 60 by simple calculations we can find out the value of p, that is 669.21, and by simple calculations again we can find out the y component here, but y component the here resultant is along the x axis. That means resultant fx is equals to r. In this way we can find out the value of r also. So r is equated with the fx summation of all x components. Already we have calculated p, so we can put the value of p here. So the resultant it comes to be 146.41. The resultant in this case it comes to be 146.41. So in this way we can resolve this forces on inclined plane also. So in today we will end this lectures. Again in next lecture we will have, or we will solve some more problems related with the mechanics. All these problems are important related because depending upon this various problems we can solve the various problems related with this. So today we will end this lectures. So thank you.